Welcome to Easy Math TV. This is another video in our statistics series, and this is going to kick off. We're going to have two videos on hypothesis testing, and I want to try to make it as straightforward and simple of a process as possible without getting into a lot of the detail, a lot of the theory behind it. So let's just dive right into a problem here and talk through how we would solve it. So the problem that we're given is the hospital administrators in a certain hospital claim that the average number of times patients ring the nurse during an 8-hour shift is 2.2. So the number 2.2 is the average number of times that patients ring the nurse during an 8-hour shift. So that we call that a claim. The hospital administrators are making a claim. And you'll notice that the word average is mentioned there, average number of times. So when when you see the word average, that is a clue that we're talking about hypothesis testing of a mean, all right? Um, so there's just some clues in the problem, and there's also the word claim. When you see the word claim, we also can get an idea that we're about to do a hypothesis test of a claim. And and then the second sentence says use the simple random sample of ring times. So we have a simple random sample. Sometimes in the problem it'll just tell you what the sample mean is and the standard deviation. But in this case, we actually have some data that we're going to look at. And so we have a simple random sample of ring times, and we're going to test the claim at 90% confidence. So if that wasn't stated in the problem, we would probably just default to 95% confidence. We would just start there. But the problem is specifying a confidence level, so we don't need to decide that. Okay? All right. So what this is just basically just walk through the process of a hypothesis test. So the first thing that we do is we write both our null and our alternate hypotheses. This is the scientific method, okay? In the scientific method, you make a claim and you want to test that claim by testing what you believe to be true versus what is the opposite of it, or what is the alternate of that. Um, so in this case, H0, which is called the null hypothesis, H subscript 0, is going to be the true mean mu equals 2.2. So we use the symbol, remember the Greek letter mu is representing the true mean. And the hospital administrators are claiming that that is 2.2. So that is not the mean of our sample. That is the mean that we are testing. Okay? So the mean that we are testing is the Greek letter mu, and that's equal to 2.2. So that makes the alternate hypothesis mu is not equal to 2.2. All right? So what I want you to understand is that the null hypothesis always represents the status quo. It's always going to use an equal sign. It will never use a sign other than an equal sign, all right? The alternate hypothesis will depend on the claim, okay? So you have to read the problem and you have to decide, is the claim actually just represented by the null hypothesis? Because in this case, the hospital administrators are stating that the average number of times is. So if they say it is 2.2, then that is a statement of equals, okay? So the hospital administrators are claiming that the number of patients ring the nurse equals to or equals 2.2. So if you can replace the word is in the claim with the word equals and it still makes sense, the sentence is equivalent to what you started with, it's the same in meaning, then the claim is, in this case, the claim is the null hypothesis. So we don't have, like, the administrators are not saying that the mean is larger than something or smaller than something. So that makes the alternate hypothesis mu is not equal to 2.2. The true mean has shifted in some way and it's not equal to 2.2, okay? So you have to use the clues that are given to you in the problem to determine what the null and the alternate hypotheses are. But you can be very you can depend on the fact that the null hypothesis will always be the statement of equals, and the alternate hypothesis is just a choice between not equal to, less than, or greater than. Okay, so you only have those three things to choose from for the alternate hypothesis. Okay, so in this problem, the claim translates to mu equals 2.2, and therefore the alternate hypothesis is mu not equal to 2.2. However, so let's consider this other scenario. However, in this situation, we have two parties that are in disagreement. Okay, so in this problem, we are also going to test a claim that was made by the nurses' employee organization. And the nurses' employee organization is saying that the average is actually higher than 2.2. They're saying, no, we just don't have enough nurses on staff because the patients are ringing the nurse more frequently than you think. So they're claiming that the average is actually higher than 2.2. So to test the nurse's claim, we would use the null hypothesis is still mu equals 2.2, but the alternative hypothesis in their to test their claim, we would have to use the alternate hypothesis that the mu is greater than 2.2. So use the greater than symbol because that's what higher than 2.2 means, okay? So the good news is that the spreadsheet that we are about to set up, once we get everything typed in, we can actually use all of the numbers that come up in our calculations to perform both of these hypothesis tests at the same time. Both of them are going to have 90% confidence, okay? So we can test the hospital administrator's claim. The hospital administrator's claim. We can test their claim, and we can also test the nurses' employee organization claim, all at the same time. Okay, so this is just your introduction. I'm going to just put this video up as a way of just showing how to construct the null and the hypothesis test. I'm going to put this video up as a means of showing people how to construct the hypotheses, the null and the alternate hypotheses, okay? So that should give you an idea of how to write the null and alternate hypotheses. And then we will, in the next video, we will actually just go through the process of performing the test with the data that we have.